Professor Nitin explained about the integration of real-time data in mapping vulnerable zones of flooding during flash flood events. Our next speaker was Dr. N. Purnachandra Rao, Chief Scientist, NGRI, Hyderabad. He discussed about the environmental seismology, a new tool for monitoring and early warning of geohazards. Professor Rao elaborated the applications of environmental seismology in understanding the disaster. He also explained how this can help in early warning and act as a precursor of disaster. Now, moving on to today's session, we have 2 lectures followed by 1 demo. Our first speaker for the day is Dr. Amrit Lal Halder, Consultant, Flood Monitoring Cell, NIDM. Dr. Halder obtained his post-graduation degree in Exploration Geophysics from Indian Institute of Technology, Kharagpur in 1985. He received his PhD degree from Vikram University, Ujjain, Madhya Pradesh in the year 2003. After passing out from IIT Kharagpur, he served in Danish International Development Project, Govt of Odisha, Bhubaneswar as geophysicist from 1985 to 1988. Thereafter, he joined the Remote Sensing Applications Center, Uttar Pradesh, Lucknow as Scientist SC and elevated up to Scientist SG. He also worked on geophysical exploration of groundwater on hard rock area of Bundelkhand as well as alluvial area of entire UP, remote sensing, GIS and DGPS, LIDAR and bathymetry. He has done numerous works on cadastral resource mapping for the state of Uttar Pradesh. He has completed more than 38 projects sponsored by national, international, state of Uttar Pradesh and other states. He was appointed as the Director of Remote Sensing Applications Center, Uttar Pradesh for a duration of 2 years and got superannuated in March 2020. He is presently working as consultant, Flood Monitoring Cell at National Institute of Disaster Management, Ministry of Home Affairs, Delhi. To the credit, he has 67 technical papers in various national, international journals and also in symposiums. He has visited many countries like France, Switzerland, and Italy for various technical projects. I invite Dr. Halder sir to deliver his lecture on modernization of land records using high-resolution satellite data and their applications. I welcome you, sir.
Thank you, Dr. Kamalnidhi, for nice introduction. Now, good morning to the expert, participants, and the staff of SRIMT, NIDM. I hope it is audible properly. I hope it is audible. Okay.
Yes, sir. It is
now we can share the screen also. So today you have learned that what topic I will dealt here in this first lecture, and that is the very important topic. That is the cadastral mapping. You know what is the importance of land record. There is a land record is the present day central government and all other state government. They have taken a very important role, a lot of precaution so that disputes could be reduced. So how the high resolution remote sensing data could be used for the modernization of land records. For that, I'll try to speak on that. Let me share the screen. So please share the screen. It is not, Dr. Kamalnidhi, please share the screen.
Yes, sir. I have given permission to share, sir.
Okay, okay, yes, it is coming now. I hope it is visible.
Yes, sir.
Is it in a full zoom or?
Sir, you can make it a slideshow view, sir.
Okay, just 1 second. I hope it is in full screen.
Yes, sir. Yes, sir.
Yes. So, you know what is cadastre. Cadastre basically the property of lands, and that is depicting the boundary of the parcel and it also having the ownership and all the rights of record. It is there. Now, so so there are two main important components in the cadastral map. That is parcel boundary, and second one is gata number. That is one unique number for each parcel. It is there, as well as the boundary. It is there. So you have seen in the right side that map is there, where each parcel are nicely and precisely depicting in a black color or somewhere blue color. It is that, and within that, essentially in center portion, one number is there. This cadastral map is having in different state, in different scale, starting from 1:4,000. Exactly, it is 1:3960, and somewhere it is 1:5,000 scale. Even 1:8,000 scales are available. And most of the most of the states, so say the village, they are having, if it is say 400 numbers, but the cadastral map will be more than 400. Somewhere it is 800, somewhere it is 600, almost 1:1.5. If it is 400 in average, all the state in average, it is typically having 600 like that. So in India, when the cadastral survey started, you might be knowing that GSI was established in 1767. That is more than 250 years back. That GSI has taken into account the cadastral survey after the establishment of their own setup. And they have continued till 1904. After that, each state, they made responsible for the cadastral survey. And prior to that, the cadastral map utilization has been started in Netherlands, that is in 16th or early 17th century. These are the certain background I should tell before coming into the modernization. So at the time of Renaissance in Europe, in the emergence of capitalism, they have started to control the land by means of production of crops and other purposes. So different farmers, different people, they were to control them. This type of cadastral survey started, and the map was produced. And nowadays, in India, with the use of present this high resolution satellite data, GIS technology, and this land information system, it is very easy to map or to assess the cadastral map and preparation of soft copy and updation of soft copy. You might be aware the central government, that is Rural Development Department, under the scheme of NLRSS, that is National Land Record Modernization Program. So they have started more than 12 years back. There, it has two components. First component is the preparation of soft copy. It means that whatever cadastral maps are there in hard copy, and that has to be made soft copy, and it has to be in ArcGIS format. So it means that it should be a safe file, and ArcGIS it can take immediately, and further work will be done. So that way the first component. And second component is the survey resurvey. It means that earlier, say 50 years back, one big plot was there. That plot nowadays somewhere it might be splitted into many parts, maybe 2 parts, maybe 4 parts, like that, depending upon the generation. First thing, second thing, somewhere someone is purchasing, somewhere someone is selling. So I mean that all those parcels are getting smaller in size, smaller in pace, and ownership has been changed. So like this, everywhere, all the states, they got this type of status. So now it needs all those parcels to be put in one platform or one window. So it should be, ownership should be updated, and landholding should be updated, and this parcel boundary to be updated. Even if you update it, you can see what type of props are there. All the things could be made. So that's why this high resolution satellite data and this modern technology, it means that this remote sensing technology, GIS, and also it is very, very need that GPS technology rather than DGPS, differential global positioning system. These are the very, very required aspects or parameters or inputs to make the modernization of cadastral map. So what are the significance or what are the utility of this computation or the make soft copy of land record? Main important thing is that for the better maintenance, you do not know that what are the top thing for maintenance of the hard copy. It is very, very tough to manage, to maintain, and a lot of problems are there to maintain the hard copy. And availability of data, each and every. If you are having soft copy, it can be available everywhere, even through the website or in computer. You may be sitting saying abroad, but you can access your cadastral data. So that's why it is very, very essential, it's required. And also, what I told you, that time to time persons are selling the plot, and somewhere due to the generation it is splitting. So hence it required to update the cadastre with the ownership as well as the boundary. So regular updation would be easy if the computation would be there. Similarly for land use study, and you might be knowing the earlier only in Kharif, the Kharif crops was there. In Rabi season, that crop is there. Apart from that, nowadays, varieties of crops are going on. So to study the land use, if we are having updated, then it would be immense use to use those cadastral maps in soft copy. And also these records of rights, that means somewhere it is a Khatoni and somewhere it is a Khatian, different forms are there. That is very, very essential to preserve, because earlier it was maintaining in some office, the records of rights means Khatoni, and somewhere it is maintaining the map. So that was a very big gap and very disadvantage to use those properly in proper time. And also various social engineering purposes. You might be knowing that social engineering is also quite important nowadays, not only village level, in urban level, peri-urban level, it is there to make the social engineering very easy. That soft copy of cadastral maps is of need of the hour. And also the various watershed development in micro level, nano level is going on under different scheme of central government. This cadastral map is the main part, that is the main unit that is essential. And also for village resource center, in village, different resource center, time to time, they are creating not only village in other urban places also, but the cadastral map will be the first step that needs to make it planned and viable for the scheme. Now, what is the prevailing scheme, prevailing system? You know, the cadastral maps is prepared somewhere in 1:4,000 scale. They are either paper, they're on either on paper, the media. It means they are either on paper or butter paper, or say this tracing sheet, and somewhere it is cloth media. Cloth media means that is in oxycloth. It is there. That is the amalgamation of polymer and this tracing sheet. It is there. It will be used because it will last more time than the tracing sheet or butter paper. And also to some extent that in the butter paper, it will be having brittleness, but here brittleness will be less, but fear is there for the fire. But apart from fire, it cannot damage. Even in water also, that can sustain and that make of easy use. It means that the script are there that will not be diluted. So that is very much essential. That is there in present system, either cloth media or in paper media. And this Khatoni, that is record register, that is records of rights, that is there where its plot number and associated information about the ownership, land holding, etc. are maintained manually. You might be very much aware of the Patwari, what is their nature of work, Lekpal. They are having full of work, but this is the one main component for their assignment in day-to-day life. But they'll be so much busy because for the starting from this vote purpose, starting from say water level purposes, starting from say this inoculation, that would mean the vaccination, all the times they'll be busy for very purposes. And they are maintaining this Lekpal and Patwari. So it will be very in present condition, and it is very, very inconvenient for the public to access them all the time. Now you see how the land record office they are maintaining. You see small sack are there or bundle is there. They are all those cadastral maps in Pargana wise or block wise or panchayat wise it kept. So you see the what is the fate of the records now and how much space they are taking. That is this is one record room in Uttar Pradesh land record office Mou district. Now how much space they are taking. But if it is in soft copy, it will within the one computer, entire state, not only entire state, entire country, the cadastral map could be kept. And it will be in safe condition, it will be dynamic lock, and nobody can interfere, nobody can access easily except the authorized person. Now, you should know what is the most advantage of the present system. Present system means this is modernization of land record. You know, the digital version of cadastral map, once it prepared, that it could be age matched very easily and very properly. And thereafter, it can make a seamless map for the entire block, then thereafter a tahsil, thereafter a district. And finally, it can seamlessly make a single map that is for the state. But whereas in the hard copy, it was very, very difficult. You might be knowing that one cadastral map, and below that cadastral, if you match it, then there will be gap or somewhere it will overlap. But actually, it is not there. But this modernization system or the digital copy or soft copy with the use of this remote sensing and GIS technology, that will be to some extent tackled properly. It means that seamless map you can generate very easily. This is the most advantage for this present modernization techniques and present system. Also, security aspect point of view, it will be very, very stringent and very, very you can manage properly. So either the security will be in the computer or it will be in the proper authority so that no one can damage or no one can say fire those property or no one can throw the water, no flood can damage the water, no termite can damage the water. So security aspect, it is of very hard and very proper. Simple objectives are there. Initial stage, you have to scan, thereafter digitize. Then, because it is digitization would be made through the software, that's why it needs validation. After that final digitized map would be ready. Once the digitized map is ready, there you have to go put the latitude, longitude. It means the georeferencing is required. Until unless each map is having the coordinates, it is of valueless. If you put the latitude, longitude in all around, then it will be a very, very meaning. It can place in the globe in the appropriate place. And it will be immense use and very easily you can tackle. And after that, that seamless map, it will be automatically generated. Once the georeferencing is made, soft copy is made, the georeferencing made it, then seamless map preparation will be very easy. So these are the different methods, these steps to prepare the soft copy and modernization. Finally, you have to go for the use of high resolution satellite data. High resolution satellite data, you know which satellite is having resolution more than 5.8 meter or more. that is high resolution. Say Cartosat 1, list 4 in Indian satellite, and in other countries satellites are there, QuickBird, Sentinel, Worldview. In the Google, you are seeing the satellite data, that is QuickBird, even Worldview data they are giving. They will be having very, very good resolution, better resolution, that those data will be of immense use, and very proper result, very good result could be given for the land record moderation purposes. So without this high resolution satellite data, it is very difficult. First thing, and second thing, that what I told you, that each soft copy, after the preparation of soft copy, you have to insert the latitude, longitude all around. It means you have to rectify, you have to validate. First, you have to purchase the satellite data. That satellite data, it needs the rectification, and the rectification, for that you need ground control point, because the land records, you have seen that scale is 1:4,000. It means 1 millimeter on map in the ground, it will be 4 meters. 1 millimeter, you know, that is in marker, or not in marker, in fine microtip pen. If you draw a line, that will be 1 millimeter, even sometimes is more. That line, it bears the value in the ground 4 meters. Now you see what is accuracy. In the, you know, in the land, that whenever that neighbors are there in one land, and if 1 feet or more than 1 feet is going from this side to that side, all those owners will be very, very aggressive. They will not allow 1 feet land from any one side. That could be managed from this cadastral map, from the soft copy. So you have to be very, very proper attention, proper steps to be adopted for the accuracy, for the validation, and for the rectification of satellite data initial stage. After the satellite data use, then we will go for geo-referencing. It means the ground control point is very important component in the land records, so that you can maintain the accuracy in the land record purposes. That's why for the satellite data, whatever you are purchasing from the NRSC, National Remote Sensing Service Center, this is the main agency to supply the satellite data in India. After that, you have to go for the rectification of the satellite data and for the use of land record purposes. So this is the outmost care we have to put, so that lot of accuracy you could develop, and lot of problems and lot of disputes could be resolved once the accuracy is maintained properly. So you see in these steps, various steps are there in quality checking. Each step you have to make the quality checking, because you are preparing in the soft copy with the use of software, and each step quality checking essential, because human errors are there, instruments errors are there, software errors are there. Those has to be minimized by using the quality checking. Suppose one map is digitizing 1%, the second man can see his map while preparing the soft copy, and also in the hard copy print, what is the error is there. So that's why quality checkings are very essential. After the main person is the Board of Revenue. That is their document, that is their essence, that is their beauty to maintain the accuracy. So finally, the land record department, land record person, they will correct it. Once they will certify, then and that you will be having confidence to use those cadastral maps. So various stages quality checking there. Finally, quality checking will be done by the revenue persons. That is the most authenticated, because that is a legal document. You know, the better accuracy you are getting from the satellite data, better accuracy you are getting from the GIS techniques, but still the hard copy, it is there, that government will believe, land record department will believe. Now it is our duty, and also this use of remote sensing of GIS in all steps, it is there, and people are believing this technology we cannot eliminate, and this is very used for the proper in the modern age. Now the hard copy, accordingly, the hard copy, the accuracy has to maintain properly. You see, this is the one sheet of cadastral maps. You know, there are 3 sources to have or to maintain the cadastral maps. First is the Board of Revenue. Second is the in collectorate, that is Abhilekhagar or Mahafis Khana. And third in the Tahsil office, that is the Lekpal, Patwari or Kanungo. These 3 sources are there for to maintain or to collect the cadastral maps from any state. Now, next, after digitization, the second component is the scanning. Here also you have to maintain the accuracy. While scanning, you have to put utmost care for the accuracy. There are 2 types of scanners are there. One is the flatbed scanner and another is the widecom scanner. In the widecom scanner, map will go one side and it will come on the other side. During that process, that occurring of error is chances are there, because that is a motor driven system. When motor will pull, then it may elongate or somewhere it may squeeze also. So, but certain techniques are there to maintain the accuracy that is there. I'll tell after that. Now the ideal scanner is the flatbed scanner, where each map will be pressed properly, no elongation, no squeezing, and appropriate scale. Even somewhere, if some map is crinkle or crinkle is there, that will press it. It means the flatbed scanner, that provision is there. So flatbed scanner is the ideal scanner. Somewhere, some maps you have seen in the store how they kept, and they'll develop the crink, and that needs to be before using this land record purposes, before using this soft copy preparation, that needs to be placed using the iron, and that has to stitch it so that no error to be incorporated. There you see in the right side that one grid system is there. In India, some of the state they are having in cadastral map, it is grid is there. But in certain states, they don't have the grid. But this grid technology can manage what I was telling you in the widecom scanner, the due to elongation, that error may come. But this grid technology can give relief to make error free. How it is that? That you know, in the right side, that grid is there, say, let it be, say, 30 centimeter by 30 centimeter. And while scanning, and if it is elongated, instead of 30 centimeter, let it be 31 or 30.02 centimeter. And accordingly, whole map is being staged. Now, this after the scanning, will be having the PDF format, JPG format, like that. Now that map could be superimposed by creating a separate grid, say 30 centimeter, 30 centimeter. And if you superimpose it, you can see that how much stretching is there. Now the softwares are there, their command is there, our setting. With the use of this technology, you can put in the original position, that is in 30 centimeter, that PDF file or the JPG file, it could be bring back to the original position, saying 30 centimeter, 30 centimeter. Like this, different techniques are there to maintain the accuracy for the cadastral maps. So somewhere this cadastral map will be very hazy, somewhere it is painted. Now different DPI is to be used, and grid marking should be there. If it is not there in manual, it is there. And somewhere, say big cadastral maps are there, that you know the size of the scanner is maximum A0 size, not more than that. But in certain places, in some it is there, the cadastral maps are more than bed sheet size, or double bed sheet size also. In that case, that you have to take the photograph with the camera, which is having more than 10 megapixel capacity. With that, you can manage to have a single frame, or else in part by part, you can take the photograph and thereafter you can make a single mosaic. So somewhere if the map is not grid, then here the grid has to be superimposed and you have to scan it and for proper maintaining the accuracy. So what I was telling, by using the camera, you can take this big size cadastral map photograph for the for making the digitization and JPG format. Even somewhere so much big are there you make it splitting or cut into pieces. After that, you can stitch it in different softwares. Now it is there in TNT MIPS and certain softwares are there, where using the stitching, you can put a single map in JPG. So scanning is over. Now you'll go for digitization. There are different softwares are there, and very ideal software is the AutoCAD, and because it is very cheap, and parallelly ArcGIS is also there. In AutoCAD, very fast you can do, but ultimately from the AutoCAD you have to compatible in ArcGIS. It means you have to convert in shape file. So different formats are being assigned. Say in layer, what is the text, and the description, what are the items need to be described. In color also it is there, and font is there, and height, all the things are there, and different symbols. So survey pillar is having separate identity, and abadi, fonts, oil, different symbols are there. Now you see in the AutoCAD, so while going for digitization, each layer, say if it is road is there, road will be having one layer. Now parcels are there, that will be another layer. Somewhere it is Nala is there, or Nali is there, that will be separate layer. In the right side, you see different layers are there. So here it is the settlement, here it is the, say, some land use purpose is there, somewhere the somewhere's a river is there. So different layers will be prepared by the this AutoCAD. Finally, that which was single layer in the left hand side, you see this is shape file. It is you have to finally you have to go for the use the ArcGIS, and it needs a single layer, that is a shape file format. Now it is ready in ArcGIS format. Here we have to go for the quality checking, because to avoid the error, to achieve the utmost accuracy, the quality checking is very, very essential. Now for quality checking, you have to take a print, check print, and that is to be essentially on butter paper or transparent sheet, and that will be given to the land record department for quality checking, so that initially they'll match it the entire area, and if it is there, they'll mark it how much is been elongated or reduced, and snapping errors that will be checking in the soft copy. Somewhere it is missing of gata number, plot number, all the things they'll check it and they'll send it. So what I was telling you, the check print is essential, that is there. Now this for the validation purposes, the concerned person, they'll check it. After the checking, they'll highlight and they'll sign it. Basically, this person, it should be from land record office, so that maximum things it could be highlighted and maximum error could be reduced. Now, next step is coming, the use of high resolution satellite data. The dataset 1, that is having the resolution 2.5 meter. Nowadays, dataset 2 is there, 1 meter. Quick bar is there, 1 meter resolution. In those maps has to be achieved or procured, and from there, that you see the bottom, there are certain maps. Road junction is there, somewhere Nali road is there, somewhere field burns are there. These features are to be identified in the high resolution cadastral map, high resolution data, that will be easily you can visualize, and those points are to be traced in the ground. There you can collect the ground control point to this rectification of the satellite data. So at least 4, even it should be better, more than 4. So if you take 6, 8, 10 ticks are required, say for 10 kilometer by 10 kilometer area, or even if you take better, that would be better. Now the DGPS, you know that what is DGPS? That is a differential global positioning system. That here, that it is basically functioning using the satellite, different constellation of satellite. More than 24 satellites are there. While making operation in the DGPS, DGPS will be having two units. One is base, another is rover. Now, to fix the base, it will take a lot of time. Earlier days, it used to take more than 3 days, but nowadays, sophisticated base station are there. Base is there. Within a day, you can make it. Now, the constellation of satellite, while preparation of the base, you have to see that more than 8 satellites to be visible. And that station, it should be it should not be interrupted in power. It should not be jerked. It should not be fall down anywhere. So that proper accuracy could be maintained. Once the base is established, that it will compel the rover to collect. So rover, and also the rover should move. So almost 40 kilometers apart from the base. Now both the rover can collect the data within a short time, but once base is there, rover will be moving, and as much the point you can cover within 40 kilometer radius, so you can collect. And thereafter, if it is more than 40 kilometers, then you have to need to change the base. So this is the satellite data of Cartosat 1 of UP Sitapur district. Here 27 scenes are there, and this is a very big district, and we have collected more than 100 GCPs for the rectification of the satellite data. These blue colors are there. Those are the that is latitude and longitude in that places. And so after the mosaic, the rectification, that seamless scenes are prepared, and there the entire district boundary placed, and you see the red colors are the Tahsil boundary. Now you see this is a quick bar image in the left hand side. Here you see road junction is there, which is visible here. This is metal road and this is Kacha road. It is there. So these points are to be identified with satellite data, and on the ground it is to be collect the GCPs and with utmost accuracy, so that you can achieve the in millimeter level, if not millimeter, on centimeter level accuracy. DGPS you can achieve record. Now, main purpose is that the satellite data is ready, seamless map is there. Now we are having the shape file of the cadastral map. The shape file need to be georeference. Now for the shape file also, it needs at least 4 points. You see here one road junction, here also road junction. Like these 4 points are identified. 1, 2, 3, 4, and almost in equal interval all around the map you should collect, and that should be placed in the satellite data. If you transform those points, then it will, this map will come into this satellite data. Now you see this georeferencing is done. This cadastral map is being placed on the satellite data. Here you can see the parcel boundary, that is yellow color, very nicely visible, and you can see the updation. Somewhere the cadastral maps are splitted, somewhere zoomed, somewhere road is going from old direction to other direction, like this. So very this updation of the cadastral map could be done once the rectification is over. Now you see this is also rectification is done. Here the earlier road was here in this color, and here present road is there. So like this type of shifting and changes are done. Here the road is going in the same road, like this. The after georeferencing, all those things should be nicely visible. So what I was telling, after the georeferencing, the updation of spatial data is very possible, and that is required for the modernization of cadastral maps. Now you see one map what I was showing, that here that one big parcel is there. Here it is split into more than 14 plots. Earlier big parcel, like this one road is there, so white color is there. That road is being developed presently. In the satellite data it is there. It means the blue color that is updated, the cadastral maps, but whereas the yellow color is the cadastral old record of cadastral maps. Now here you can see the discrepancies of the plot boundary. Now here again we need the validation because it is prepared the soft copy. Now it has to be validated each at least certain parcels from their accuracy you have to obtain. Until unless accuracy is there, you have to go for again repeating the scene because no owner will allow the 1 foot land from this side to that side. So that's why this is very, very essential, this validation in each and every step. Once the validation is over, map is ready. Now we can put the seamless map. Now you see red color is there, that is for one block. That is for one village. Similarly for green color, that is for another village. That is a parcel boundary. Like this, you can prepare the seamless map for a panchayat. Now from panchayat to enter all those blocks for a district, you can make the seamless. So this is the beauty of the modernization of cadastral maps. You can nicely zoom it, nicely make it seamless. Now another important thing which should be resolved by this
incoming and outgoing under ki.
Now you see this this yellow color map is there. That is one village Mundera. That is the cadastral map. But whereas this black color map, you can see Mundera, that boundary is separate. This is also village boundary. That village boundary is using by the census department, but this cadastral map that is using by the Board of Revenue. But both are from the same village, but the shape and size both are different. Now, which one you should believe? You should believe the cadastral maps. From here, you know that one brick with another brick in a house that will make the complete house. So that's why one person to another person like this, it is making an entire village. So the village map, which is of form of this cadastral map, that is ideal. So that has to believe. That's why it is present need of the hour is the cadastral map preparation. Now it is ready, the soft copy of cadastral maps. Once ready, then you have to use it. For various purposes, it has use. You might be knowing the consolidation. In certain states, earlier it was their consolidation or chakbandi work, especially in northern state, it was northern state of India, it was there. And this consolidation work that can make a lot of simplify, lot of time saving, lot of money saving by using this modern technology, remote sensing and GIS. Similarly, this micro watershed level mapping, central government, they are carrying out IWMP, Integrated Watershed Mission project, that is this micro watershed level mapping is required. Similarly, for utility services mapping, parcel-wise flood assessment. In the flood, you do not know how many parcels are being inundated, how much crop is being damaged. Now, this parcel-wise flood inundation map, that will be very, very useful for the village or for the district authority, for the relief commissioner. And similarly, for the zodiac land, in certain state, they are having this sodicity development. Their parcel-wise sodicity map can give lot of relief for the proper updation of the sodicity. So this is one example what can be done by using the cadastral map, by using the modern technology for the this consolidation. You see, this is the entire map of a village. Now, Pottery, what he will do, he'll measure manually each and every parcel. For that, for the small village which is having say 400 or 500 parcel, he will take 3 months. Whereas by using this remote sensing and GIS technology, it needs only to collect certain DGPS points that may take maximum 2 days for say village of 500 parcels. So that much is the groundwork is there. Rest of the thing, but whereas the Pottery, he was taking with his team more than, so at least 2-3 persons involved, more than 2 to 3 months, and a lot of errors. You do not know how much error is there, but this technology can reduce the error. So this is the Swajra map is being digitized by the ArcGIS. Now DGPS points in that village with the interval of say 400 meter or somewhere 450 meter distance to achieve the accuracy. That's why close interval points are taken in this Mother R2, Mother R3. That is the name of the village, Madarpur, and R1, R2 Ruhar points are taken. Now you see, this is the boundary of updation. There's the black color is the old boundary, and the yellow color is the present boundary. Now you see that how much deviation is there from the black and yellow. In the northern side, you see the more than 10 meter shifting is there in village boundary from one place to other place. Now this GIS and remote sensing technology can give the accurate picture, can give the proper visualization for the shifting of the village, for the shifting of the land records from one place to other places. Somewhere it is shifted, somewhere it is enclosed, and somewhere it is within the parcel, some other villages have been there. So this is the beauty of this modern technology. Now you see there are two types of the red color and black color. Red is the old and black is the present parcels. And within this consolidation, that some forms has to be filled up. Finally, they will fill it up for measurement of or at the time of survey. So that form, of course, before filling the form, the validation is there. We have made the validation here. Say in the western side, it is 15.5 meter, whereas it was earlier, it is 15.3 meter. Means 0.2 meter is there. That is within the permission limit. So each and every parcels are being validated and checked to achieve the accuracy. This type of form has to be prepared. This is form number 24A that is there. In the Hindi, it is written. Each parcel length and width to be given. But in GIS, once you move the cursor, you can get the length. Instead of putting the chain here within the cursor, you can get the length. And also, you no need of drawing the picture simply from AutoCAD or from shape file, it will come to the shape like this. So how much easy is there? So entire work for the survey work, it has taken only 7 days. For that Lekpal will take more than 3 months. And for the filling of the form, that he will take another week or 10 days. So instead of that, this GIS is so easy, so user-friendly. Another form is there, that is from the Khatoni, it has to take. And this can be also from the Khatoni, you can download or you can collect and you can make update and you can fill up the form number 2. So that was the one work we have done for the survey work for that. But the entire work from the initial stage to final stage, that to prepare a final chalk you can do with the use of remote sensing and GIS. But of course, in between the certain steps are there for the hearing and other thing. That time has to be given because villages, you might be knowing, a lot of litigation is coming on old, say quite old. And those has to be sought out while preparing this one, while preparing this chalk, final chalk. So for that, some time will take. Rest of the time, that is in your hand. Now, another is the utility facility mapping. You know, in the villages, different utilities are there, say hand pump, say toilet, say transformer, like this, say temple, and they say Kharanja Road, and this light, that is the solar light, or say other light for the illumination of the village. So these are the utilities, it is available in the village, but in the cadastral map, it can mark it nicely using GPS, DGPS, or the soft copy of cadastral maps. And you can prepare the map. You see the for hand pump symbol, you can place it in somewhere. Similarly, you see how much big is this settlement. That you can prepare nicely. It is visible and properly. You can prepare with the use of satellite data and cadastral maps. And in UP, or also in some other states, different schemes are there. Nowadays, it is there, the Adarsh Gram scheme is there. In the Adarsh Gram, the government is uplifting the village wherever the facility, say drinking water facility is there or not, say gas connection is there or not, electricity is there or not, or in different scheme, they'll be having different norms to update. So earlier, Ambedkar village was there. Thereafter, Lohia Gram was there in UP. And nowadays, Adarsh Gram is there. In different schemes, all those could be monitored by using this high resolution satellite data and GIS. We can. Just one second. Sir, time is over. Just another 2 to 3 minutes, please. It is. So it is one of the village Adarsh Gram where the toilets are being geotagged, and like this, water schemes are being geotagged. It is there. This is the entire village where all those toilets are being prepared. Sometimes like it is there, it is geotagged. And similarly, it could be used for the watershed purposes. You see, different micro watersheds is there. So almost 14 micro watersheds are there in one watershed. So all those watersheds need to be mosaic, and for the proper implementation of the scheme for the watershed development, it is there. So initially we prepare the watershed, and thereafter different structures has to be filled up. It's a agro-horticulture. So for agro-horticulture, that is broadly defined, that is where the vegetables, fruits, flowers, crops, different crops could be put in the field bund. That would be the agro-horticulture scheme. So that has to be identified in parcel wise. Similarly, for check road bund, you know, in the villages that enter, different check roads are there. That check roads are getting damaged. To get prevention, this check road, you have to put the check road bunds are there. Say, and so in the next map. And similarly for contour bunds. So here, this is the in the left hand side, you see this is the contour bund is there. Main focus is that to save the soil, to maintain the fertility, and the water should percolate. This is the main funda for the contour bund and for different structures. So to be used properly. And here you see, this is the place where the agro-horticulture scheme is there. And similarly, check dam. Here one check dam is there. Check dam that will be used, the water should percolate so that different bund will be there. The water will be arranged so that it could percolate to the ground. It cuts off the runoff velocity and reduce erosivity. And the water will be stored, improve the soil moisture, and it will percolate in the aquifer. Similarly, for peripheral bund, somewhere some rivers are there. In that rivers, the peripheral bund structure to be placed. And similarly for desiltation. And most of the pond or river that will be filled with silt. Now, if you desilt it, a lot of merits and demerits are there for desiltation. Mostly it is merits are there. And for the desiltation, you can increase the water holding capacity. You can increase the groundwater recharge, all the things. So different, these type of things, structures will be adopted. Now you see in each parcel, this is one village here in parcel wise. In the bottom, you see in action agroforestry, what are the parcels involved and total length. Say 2 numbers agroforestry scheme is given and length is 3.23 kilometers. In parcel wise, you can put the statistics. Similarly for agro-horticulture, desiltation, check road bund, contour bund, peripheral. All those statistics are given for a cadastral map. Now, this is another important thing for the flood purposes. Now for the flood, you know that during flood, the entire village, somewhere it is inundated, somewhere some parcels are there. Now you do not know how many parcels are there. If you count it, or the lakefall at that time, due to the grasp of flood, they cannot move. Now you are having the satellite data from the radar sat or from the NRC. If you collect it, now you superimpose, then you can visualize how many parcels are inundated. So this blue color, that is the flood inundated parcel area, and you can count how many parcels are there. Similarly, if the flood water remain more than 3 days, 5 days, or 7 days, then crop would be damaged. Now we can calculate the parcel-wise crops in each cadastral map. So this is also the flood inundation map. So sometimes in the bottom, see we say due to the cotton, the boundary is shifting from the from in the village in the river from one side to another side. Now this is another important thing in Bundelkhand. Bundelkhand is full of granite, full of banjar land is there, where land holding is very, very big. Now once you are having this cadastral map, you can plan it for the industry, you can plan it for different purposes. So that's why cadastral map is very essential to plan and for the development of the country, for the state, and for the village. And another important land is the Bihar, that is the ravenous land. These ravenous lands are quite elongated, and if you're having the map, you can plan it for the removal ravenous, but it is very costlier. But there you can put some plantation, and a lot of trees could grow, a lot of benefits, a lot of medicine you can develop. So this cadastral map can help. Similarly, for the zodiac land, you know those zodicities are developed in certain states. A grade, B grade, C grade, different categories. Using the satellite map, you can categorize the C class. C class means red land is there where no crops are there. So much zodicity. A B class is there where at least one crop is there. Now, if you maintain the land by using gypsum and other things, then from C class, it can reduce the B class. It means you can develop one crop. And from B class to A class means two crops. So for that, the monitoring and other things are needed. That is using the high resolution satellite data and temporal data in various times to time. So this is the zodicity map in parcel wise. That is the fade color. The white colors are the zodicity affected parcels. Now, finally, I conclude the up-to-date parcel level information is the need of the hour, and it is every user department presently and stakeholder, they need it. That is the very, very essential nowadays. And parcel level information on flood is very useful for the compensation of farmer. Now, modernization of cadastral maps are the need of the overall. Now, thank you very much for that. Over to you.
Thank you, sir. It was a very nice presentation. You've explained well about the significance of computerizing the land records using different scanners, and also the elaborated methodology for cadastral resource database mapping. And we have one question, sir. I invite Dr. Purushothaman to carry over the question answer session.
Thank you, Dr. Kamal. Thank you for a very good informative presentation, sir. There are two questions. One is one request from one participant that the charts which you showed in Hindi, is it available in English?
Please repeat once, or let me check the question.
There are some charts. For example, you showed the calculation chart for the Chakbandi, where
Yes.
you have calculated and you have taken the area.
Yes.
That. So the participants wants to know whether it is available in English or whether the methodology can be available so that they can use it.
Yes, yes. Each state, they can go to each state remote sensing. Each state is having remote sensing department, or say some stakeholders who is conducting the remote sensing and GIS. From there, they can know the process. That basically it is the use of this high resolution data, cadastral map, and from there they can do. Those who are having some amount of knowledge in remote sensing and GIS, they can prepare. Of course, that is a very cumbersome process, and where it involves a lot of accuracy. So that's why the state remote sensing application center, they can contact them, or the Chakbandi department, they contact wherever Chakbandi work has been done. So that from there they can collect their knowledge, or they can collect the steps like that. But all the steps I have described also, if they have listened carefully, they should know. But it could be available from the state center, remote sensing application center.
Thank you, sir. And one question, I think the participant got the answer from your presentation, but still I want to post it. The question is there any method that can be used to convert videos into maps? Because they want to derive road maps.
Can you please repeat once?
Is there a method that can be used to convert videos into maps?
Convert which one?
Videos into
videos,
maps.
Yes.
Yeah, into maps.
Videos. This is the process from the IT department and other fellow, they can tell. Definitely, that could be there. From the video, you can take the photograph and snap it, and from there you can prepare the map. But of course, the entire video, if you can map it, I cannot say right now. This is not the question from my level. The answer, I cannot give the suitable answer. They can contact through the IT department or electronics person on that.
Thank you, sir. Thank you for your very informative presentation. I hand over the session to Dr. Kamal Nandini to invite the next lecture. Thank you, sir.
Thank you, sir. Thank you, Halder, sir. Our next speaker for the day is Professor S.S. Sridhar. Dr. Sridhar, Professor, Department of Computer Science and Engineering, SRM ISD, is an active member in Earthquake Research Cell, SRM ISD, since 2012. He has completed his PhD in Artificial Neural Networks from SRM ISD in the year 2015. His research interests are artificial neural networks, pattern recognition, and image processing. He is the Vice Chairman, IET, Chennai Local Chapter. He is the coordinator for Wipro Mission 10X Faculty Empowerment Program from 2008 till date. He was also the co-convener for International Conference on Advances and Emerging Trends in Computing Technologies during June 2010. To add up to his professional experiences, he is a member in IEEE and IEEE Computational Intelligence Society, Institution of Engineering and Technology, ACM member, and also member in ISTE and ISCA. He has many publications in reputed journals. He is also co-PI in several projects. I invite Dr. S.S. Sridhar to deliver his lecture on Big Data Analytics in Disaster Management. I welcome you, sir.
Very, very good morning to one and all present here. I think my screen is visible.
Yes, sir.
Are you able to see my screen? Okay.
Yes, sir.
Okay, so today's talk will be on big data analytics and disaster management. Hope I will try to cover up within the time frame. So if you maybe these are the topics which I would like to stress upon, because many of your colleagues would be from civil engineering department. Of course, you are working with a lot of data. So first of all, you should understand what do you mean by a data and what are the techniques and tools available. For example, machine learning and deep learning. These are the buzzwords which are used currently. And I will touch upon the second part will be your portion like disaster management and what are the sources for data collection. Of course, many of the things would have been covered by earlier speakers, but I would like to share some of the online data sets. And also, what are the various tools and techniques in big data, IoT, and machine learning. And we did a pilot project 10 years back, which was actually a numerical simulation model. I will just highlight those screenshots and also some tips for researchers at the end. So for example, let me start with what is a data basically. I think this many would have come across. So data is nothing but facts. A simple fact is, suppose for example 6.34, it's a number. Okay, you try to associate with something or in a particular context. Suppose it could be a height or a weight or whatever it is. Then it becomes an information. Then when we understand, make it as something like more informative, and the context changes into a subjective thing, then it becomes a knowledge. Then finally, we wanted to understand what are the basic principles behind why this data is coming and all. That's a basic thing behind data science nowadays. People talk about data science rather than analytics nowadays. So that is basically a wisdom. So this will tell you what is the level of understanding versus the context independence. Okay. So when the level of understanding keeps on increasing, context dependency keeps on going. Okay. So it vanishes. So from the data, what I was talking about facts, when you try to understand the relations, then you get an information. When you try to understand patterns out of it, that's what machine learning and deep learning are doing. Then you can derive knowledge out of it. Then based above all, when you try to understand the principles behind why this data is coming, so that is a pure data science and analytics, that's wisdom. Okay. So for example, what do you mean by a hypothesis? Hypothesis is just to make a guess. Okay. Who is going to be the winner for IPL, or where the disaster is going to strike next? So these are all some of the predictions what we make by some models or by human expertise. Then it becomes a hypothesis. So it is basically a guess or a prediction what you make. Okay. So it can be disproved also. So that is called a hypothesis. What is the goals of learning? Okay, what do you mean by learning? Learning is just to improve the quality of communication and decision making. See, learning happens only when we have some data and we derive some patterns out of it, and then through the models we do it. Okay, so first you have to formulate a hypothesis, verify that hypothesis, then from that you can discover patterns, then predict the future trends. So this is a very, very basic steps of learning and what is the goals of learning. There are two approaches, very famous approach, top-down approach and bottom-up approach. So in top-down approach, very traditional hierarchical manner, you generate ideas, then you develop some models and then validate the models. Okay. But in bottom-up approach, from the bottom level, from the entities, you try to derive patterns out of it, then discover new patterns and then the relations. So it keeps going from bottom up. Okay. For example, you can see the picture here. This is a mall. Suppose randomly I say, read the second statement, the visitors coming to the mall earn a monthly income of at least 50,000. This is a very, very vague statement. Somebody has made this statement. This cannot be verified unless a hypothesis is built on that. Okay, so we need some data about who are all the customers coming, their income and everything. Then only this could be verified. So unless it is verified, it is not a valid statement. For example, in bottom-up approach, suppose most of the men who go and buy cell phones, they also buy cell phone cover. Okay, that means that is a trend basically, because it can be verified very easily. And also this is a bottom-up approach because we come from the basic information of cell, and along with that cell phone cover is coming. So we can build a model over that. Okay. Why we have to learn, first of all? See, these are all the four, not only these four, there are so many other factors. See, for example, human expertise does not exist in some places where navigating to Mars, you don't know, you have to explore more. Okay. Humans cannot go there. So in that case, we have to learn something. Okay. Humans are unable to explain. That's called speech recognition. It is still evolving. And solution changes in time. For example, it dynamically changing problems. Okay, that is also, we need to learn something out of it and adapt it to particular case or user biometrics or something things. Even say for in your disaster management kind of thing, certain things could be predicted, certain things could not be predicted. Okay, so for those kind of things, we need a model or we need learning, not like just calculating a payroll or anything. You don't know, we don't learn anything there. Okay, there are various techniques. I will not go into the depth of all these things. See, first of all, when you collect some data, it should be clean, it should be integrated, and it should be transformed, and it should we should reduce so that it fits into your model. So these are the traditional methods which we adopt. There are various technical methods. I'm just listing out only the basic steps here. Okay, so all these kind of pre-processing we do, and then we prepare the data for learning. Okay, what is machine learning? Okay, so machine learning is basically a part of artificial intelligence. Earlier it was only artificial intelligence. Then they build machine learning, deep learning, stuff like that. Okay, so it is an application where it has the machine is supposed to be a program. It has the ability to automatically learn and improve from experience. See, for example, if you see the left side diagram, data and rules are given. Okay, in early days we used to write code in Pascal or C or whatever it is. Both data and the rules are the programs what you do. It gives you the answer. But nowadays what they do is they provide both data and answers to the machine. Okay, that means a program. It develops a rule. Okay, the rule is actually developed. You can call it as a program is being developed. That's a model. So that's the difference between basically a machine learning and a normal traditional programming and a machine learning program. There are various terms used. Maybe I'll quickly go through these. Machine learning is actually dependent on your data mining, because data mining is simply collecting the facts and then storing and discovering patterns out of it. Okay, so machine learning is part of that, and then you have a lot of features, you have labels, you have models, and there are various performance measures what we use, that's called accuracy and precision. So what is data mining? Data mining is basically extracting patterns. Okay, so it's a process. Early days it was actually people used to store a huge amount of data, that is data warehousing they call it as. Then they developed online analytical processing. They were doing statistical analysis. Then later on, it picked up with mathematical models. That's why data mining is now a process with a lot of algorithms. I've given some list of algorithms. K-means, support vector machines, expectation maximization, and all those things. Okay, a lot of algorithms are there. For example, features. Features are basically the what we call it as your parameters, what you use for training. So here I've used size, edge, and all. Your label is your color. Okay, label is actually the identification for that pattern. When you take one row, that is an observation. We call it as observation or a pattern. Okay, a lot of observations are coming. It's a flat file kind of thing where we store it in relations and then pick up the values. So machine learning is purely dependent on your data, what you submit with features and labels. So when you go for supervised kind of a learning, you need both features and labels. Unsupervised, the labels could be built by the model directly. So there are categorical features, which actually the fixed number of discrete values will be there, or numerical features where values are given directly. So here categorical features are listed here. Okay. Labels, I told you, here they put salary as the label, but features are position, experience, skill, country, and city and all. Okay. So you give a numerical label, then it's very easy to process. You can also give categorical label also, but see that it is unique and all. Usually a machine learning model, what we develop will, that the international standard followed is 80-20. Okay. You pick up the data, whether it is a what you call it as satellite data or whatever land data or whatever it is, you try to separate them as training set and test set. 80% of the data goes into the training, and out of the training 80%, you can use some data for validation also. Okay. So validation is basically fine tuning the parameters. Okay, but testing is actually you're testing the performance. Okay, training is to make the system learn. So these are all the terminologies what we use basically. What is accuracy and prediction? Accuracy is how close a measured value is to the actual value. Okay, so high accuracy, you can see the middle portion, how close the measured value or to the actual value. The red one is the actual, okay, measured actual value, and measured values are a little closer. So high accuracy. Precision is how close the measured values are together. Among the measured values, how they are closer together. So if both are good, then it lies in the third quadrant. Okay. There are various techniques. I will not go into the depth of it. There are supervised learning, unsupervised learning, reinforcement learning. These are all, see, you don't have to learn the mathematics behind this, because nowadays everything has come as a package. Python is very, very popular nowadays, and people use even for deep learning, they use a lot of other TensorFlow and other things. All these models, whatever I'm showing you here, they're all built in. Okay, they are built in as packages or modules. You don't have to code. Okay, only thing is you should understand what is the data, where it is coming from, how to pre-process and supply to this machine learning algorithms. So the trend has become very, very easy, and also the approach has now become very easy. Early days, we used to learn hard code using C language and C++ or C#, something like that. And we used to code all these things as computer science person. We used to write codes for all these algorithms, and we tested, keep on doing with a lot of data sets and other things. Nowadays, everything has come as a package. So you don't have to worry about whether to do classification, regression, or clustering, or what. Everything has come as a package now. A lot of machine learning techniques are there. So what is classification? Classification is basically you try to develop the rules basically. Okay, so through the mathematical function, you try to develop the rule so that the labels are perfectly matching with the input data set. What is regression is fitting a curve basically. So here you are finding a relationship between input and output. So that's the difference between classification and regression. If you see, one good example is what is the temperature going to be tomorrow? That's a regression problem. Will it be cold or hot? It's basically a yes or no problem. That's a classification problem. Even you can see whether a patient will die from a disease in next 6 months is a classification problem. It is a discrete prediction. how long the patient will live, that's a regression. It's a continuous prediction. Okay, so both are different. So you have to identify what type of problem you are approaching. Okay, whether you want to predict as a continuous prediction or we are going for discrete prediction. So that has to be very, very clear at the first point itself. Then you have to approach the proper algorithm in your package. Clustering, very famous for you people. Remote sensing, you can see it's a satellite image, and that is being clustered. You can see the settlements and other sea levels are blue, and settlements are marked as red. Some differences are there. Some green portions are there. So it's all done by software directly. You don't have to code anything. So clustering is basically categorization. Okay. A typical machine learning components. First, you build the features, or from the historical data, you build the features and then model it. Within the model itself, we have 3 steps: build the model, evaluate the model, and optimize the model. Okay. Then you do the prediction. Okay. So this is the typical. So model building is basically, it's again automated nowadays. You don't have to develop it. The selected features are split into, the data set is split into training set, validation test, and testing set. I already told you, using training set, you build the model. So what you do is you make the system learn. The training results are there. Then you supply the validation data. That means you are fine-tuning the parameters. You can see validation results go into the hyperparameter tuning. Again, it is used as fine-tuning the model. Okay. So after training and validation, you test the model. Test the model for your performance. Okay. There are test results. I told you 80-20. That is being followed. Then evaluate the model. Evaluating the model is basically, you can do it offline or online. Offline, what we do is, from the model, you try to, all the results you take, and then do an evaluation in the sense how like accuracy and prediction and all. If it is not good, you fine tune the parameters of the model. After deploying means you try to use it in a particular online kind of a stuff. Then you measure the performance. So both offline and online, that will give you some indication of how the model is good or not. After that, you can optimize the model. There are a lot of optimization algorithms nowadays present. Even bio-inspired algorithms are there. That means they pick up from nature. All these algorithms, ant colony and genetic algorithms. So many other algorithms are there for optimization. You can fine-tune the parameters. Very simple diagram to explain what is the difference between machine learning and deep learning. Machine learning is, the feature extraction is done by a separate technique or an algorithm. Then you do a classification with the model. Okay. But in deep learning, you see that the feature extraction itself is built into the model. So you don't have to do anything. Just supply the inputs. It could be images or videos, as one of the speaker was, one of the participants was asking. Videos, or nowadays very, very popular models have come. Okay. So feature is extracted by the model itself, and classification is also done. It will predict. Okay. That's very easy nowadays in deep learning. Now coming to the second portion of disaster management, how big data and machine learning, whatever we saw, is playing a vital role. I don't have to define what is a disaster. Disaster is basically a catastrophe or a mishap or a calamity in the area arising from natural or man-made. A lot of man-made disasters are also there, just due to accident or negligence, so that human lives are lost and suffering is there, damage is there, everything. So it affects the entire ecosystem. Okay. So other definition is a serious disruption of the function of the community or a society. Say something is affecting the community or the day-to-day process, that's called a disaster. You know, that's natural and man-made. Natural, a lot of disasters are there. We see, you can pick up all these data, and there are models to store and also process these data. Okay. Not only earlier, it was actually people used to store it in a separate called database system, database management system. They develop database, and then they query the database and take all those things. Nowadays, models have come to store the data itself. Okay. So earthquake data, floods, cyclones, tsunamis, droughts, all these are natural disaster, and man-made, chemical, biological, radiological, security, a lot of other disasters are there. These are some statistics I just wanted to show you. The global natural disasters happened over the period of maybe 60 years. You can see the damage, how we have actually the natural disasters are happening because of human intervention only. We pollute the environment, we pollute the soil, we pollute the air, and that's why natural disasters are happening huge. You can see from 1970 it was very, very small. Now it was peak around 2002. I think we don't know what is the reason for that. In 2019, I have only up to 2019. You can see that it's increasing, keeps on increasing. Wildfire is also there, earthquakes are also there, and a lot of floods are happening. These are all due to man-made only. We drill, we put settlements and all those things. That's why these floods are coming. Okay. And this is a natural disaster in India. Almost 58% of land mass is prone for earthquake. You can see this is a very, very dangerous portion. I think I don't have to tell you because you are very expert in this. This area, in fact, in our university, we are having a separate cell called Earthquake Research Cell, where Civil Department, Chemical Department, and Computer Science Department, we collaborate and do a lot of work in the Sikkim area, Gujarat area, Himalayan region. All those things, we have gone and collected data, both field data and also satellite data. We are doing a lot of analysis and developing models out of it. So 58% of the Indian mass region is, land mass is prone for earthquake. And similarly, 40 million hectares, around 12% is prone for flood. These are all pictures I just pulled up from the thing, okay? So this is happening because of our human intervention. I won't say only human intervention. There are other creatures which are creating this. Hello. Okay. There are around 7,500 kilometers on the coastline, and close to 5,700 kilometers are prone to cyclone or tsunamis. You can see. Okay. And similarly, 3% of the total land is prone for landslides. Again, it again happens in the Himalayan region. So these are all some statistics. Disaster risk is increasing because of the demographics, socioeconomic condition, unplanned urbanization. This is the major cause for the, okay, whatever it is, flood or earthquakes are happening. Development of high-risk zones. People go and develop settlements in the high-risk zones. That's causing human lives. Environmental degradation. A lot of things are happening in cities. Climate change, geological hazards, and epidemics. Of course, this is now affecting the entire globe. Now, how machine learning can provide solution? See, for the necessity for disaster management is, not in all, but I marked something in red. See, prevention of danger or threat of any disaster. Machine learning has solutions because it can alert, it can throw some prediction from the available data. Only thing is you need proper data. It should be properly given to the model. Then only it is. Then preparedness to deal with disaster. It can again provide solution. Assessing the severity. That's what we are doing, because post occurrence of these disasters, we will get a lot of data, both from field data and satellite data. We can assess the severity. Okay. And also prompt response to any threatening disaster situation. We have solutions for machine learning, okay, through machine learning for all these things. And this is very popular among the civil community, that is disaster management community. There are 4 steps involved. One is after the event is over or before the event. So before the event, we can prepare or prevent, or after the event, you can respond to it and recover from it. Okay, so this is a cycle basically. So it also links to all these hazard mapping, and say all these are various what we call it as related to a disaster, and then we have solutions for all these things in the machine learning model because of the availability of technologies nowadays in big data, because plenty of distributed applications have come nowadays. Okay. Now I will give you some of the inputs for you where you can collect a lot of online data collection sources. See, for example, in earthquake data, you can pick up from the geophones, Okay, occurrence of the earthquake, geophones could provide an input, and it could be recorded in the seismograph, display it in the browser. We have a lot of softwares nowadays available. Online softwares are also available. Then you collect all those data in a numerical form. So once, as a computer science person, if I see some numbers in an Excel sheet or a notepad, CSV values, comma separated values, I get excited because I can very well pick up these data values and then develop my model very easily. Nowadays, deep learning solutions have come. Even the direct images could be given. All these images and all the things can be directly given. You need not rely on only the what you call it as the numerical data. Real-time disaster, you can use unmanned vehicles, okay, unmanned aerial vehicles. You can pick up a lot of data from the occurrence of whether flooding or whatever is happening, earthquakes are happening. Then by aerial flights like this, for drones, I think some of them are using drones for this. Earthquakes, because where people cannot go there directly, drones are helping a lot nowadays, because you get a lot of pictures, very, very quality, high resolution pictures are coming up. Okay, even at the height altitude level also, we are getting a lot of good thing. So it provides a lot of inputs for the machine learning. Okay, during disaster, it can be used. UAVs can be used, and this is very famous. In situ data collection, directly go to the place where it is there, then you collect it. Or remote sensing. Remote sensing is very popular because a lot of we get the live pictures and also the information from directly. There are a lot of stations nowadays available. We can pick up all those remote sensing things. So this will give you a very good picture of how we are getting data. So you can see from the sun, something is reflecting, and the interaction is picked up by the sensors and satellites, and then it transmitted here, and we get interpretation done, and then machine learning. You can do analysis and other things directly. Then landslide. I think Dr. Halder was explaining about these things. Pictures directly from the satellite image or field data, or you can use GPS location data. Then you can map it using GIS, and then landslide calculations directly, all these values. So this is a picture what actually we have been doing in our laboratory. You get a lot of data. You can see all these features are, and the labels are available. Directly we can use machine learning on this. Okay, that is possible. Tsunami related areas, okay, where you have geophones, and also you can pick up using satellite data. You can measurement of water pressure, send the signal to hydrophones, then telemetry communication, tsunami detect. Nowadays, not in 2005 or 4, where tsunami was, because not much technology was developed. Nowadays, good technologies have come. Even before the tsunami happens, a lot of alerts are coming, because people use, various other countries are using a lot of technologies, and even India is using good telemetry kind of thing. Then sources, these are some of the online sources where you can download data, because most of the time our research, people who are doing research are doing some consultancy, or they lack data. Okay, because it's a very, very sensitive data. Even ISRO or people like Indian kind of thing, they will not be able to share from critical informations. But they are posting, for example, in United States Geological Survey, USGS, they are posting a lot of data there. Okay, remote sensing satellite information. Then we have VEDAS, visualization of Earth observation data in archival system. It's a spatial data. Okay, they are posting it here. It's an Indian thing, kind of thing. Then we have a geo-referenced emergency events database. It's an international disaster data, both numerical and documentary information, EMDAT. It's available. So we will be sharing this slide. You can also go through this. These are all freely available data where you can use it for your research or consultancy purposes. There's another kind of thing. Sorry, the Survey of India topographical data is there. Okay, and also Geological Survey of India hazard data is available. Then you have National Remote Sensing Center, thematic maps are available. So they are providing a lot of informations. You can pick up all those data and then use it. Or we can also write to them, and then because of the, when we are doing some research, we can write to them and then they will be sharing this information. What is the challenges? Because these are all some of the challenges we also face. See, knowledge, first of all. Knowledge of geographical information system for mapping disaster databases. Proper knowledge, if it is not available with you, because experts must be available. Then only with just with data, we cannot do anything. Experts must be available both in the what do you call it, civil, your disaster kind of thing, and then computer science person should handshake and then do a lot of analysis. Of course, it is happening very nicely in private institutions also in India nowadays, not only in IITs and other things. It's happening now. Establishment of internet surveillance networks and data repositories. It's a challenge again, because a lot of restrictions are there. Okay, utilization of digital assistant based platforms, slowly it is picking up. Okay, involvement of key community stakeholders, it's also happening now after the floods and tsunami. Use of pre-established local collaborative network to coordinate disaster efforts, it's also there. Exploring potential civil military, okay, collaborative efforts. So these are some of the challenges what we face. Some information about machine learning repositories where natural disasters and data is available. For example, Kaggle. Kaggle is very famous among the machine learning community. We use a lot of, we share a lot of information, also pick up a lot of data from Kaggle. It has got a lot of, I think this is a very old thing. There are a lot of other data sets have been updated. Natural disasters, if when you type, you can create an account and then sign in, you get a lot of data. Data sets are available. Okay, natural disaster. Data.world. It is again from US. They pump in a lot of data sets into this from various countries, and you can pick up all these data. Those who wanted to do research or do some consultancy or funded projects or anything, you can pick up these data from these sources, data.world. And data.gov, it's an Indian kind of thing. A lot of natural disaster data is available again. Then CDAC, it's a Socioeconomic Data and Application Center. It's again available. A lot of other, not only maps are also available here. Okay, you can pick up all those data from these sources. FEMA, Federal Emergency Management Agency, again US based. A lot of disaster information and data is available. Okay. So how do we do analysis? First, we have to identify the problem. I already told you, form the hypothesis, then observe and experiment, interpret the data and draw the conclusions. This is the normal step what we follow in the machine learning kind of thing. Again, for your analysis, this is disaster analysis using big data analytics, the same thing is applied. This is another very interesting slide. You can see various technologies which are being used for disaster management. Okay, for example, data sources. Nowadays, they don't only rely on remote sensing. A lot of IoT solutions are come, sensor networks are come, social media streams are very, very popular nowadays. We get, because we do a lot of research in social media streams. Okay, both Twitter, whatever streaming kind of thing is there, immediate alerts are coming and immediate people share information. So we pick up a lot of, what do you call it as, natural language processing is being done in social media streams. That gives you a lot of information. Okay, geoportals and all. Then key components, system architecture, storage capacity, programming model, GIS based. These are all some of them. Then access technologies, LTE, okay, long-term evolution, and satellite communication, low range kind of thing called Zigbee, Bluetooth, where a limited range region we can use them. Low band radio frequencies, Ethernet. These are some of the technologies being used. Quality parameters, what we measure is accessibility, timeliness, credibility, accuracy, and completeness. And this is a very important portion. See, data analytics, social media analytics, we do a lot of natural language processing and text mining. Sensors will give you good input, both in terms of it can provide good input for the deep learning stuff. Swarm intelligence, more of optimization problems we are using. Convolutional neural networks, we are using CNNs for image and video nowadays. We are not dependent on traditional machine learning model that is very, very suited for normal numerical data, but very popular in video streaming and other image kind of thing. Convolutional neural networks are very popular nowadays. More accuracy is also there. Then geospatial data analytics, spatial temporal visualization, and other. So data analytics is now become very, very easy nowadays, because you don't have to code, you don't have to write anything. Every technology, every technique or every model is available as a package nowadays. If you are good in simple programming language, even if you know only one programming language, that's more than enough. Even Python, you can learn it in just 2 or 3 days. Okay, you should know where this package is, how to use it. Nowadays, a lot of online courses or videos are available in YouTube to learn Python or whatever TensorFlow or deep learning stuff and all that. So you need not be a computer science professional. Okay, that's what I wanted to tell you. The objective is to do real-time monitoring, okay, damage and logistic estimation and other things. Disciplines, ontology, very, very popularly used nowadays. Okay, so ontology and data mining are hand in hand, they are going nowadays. Okay, machine learning, of course, I told you, GIS and other things. So this is a very, very important thing where you can see they're both in terms of technology or the hardware side, and also on the analytics and software side, what are the parameters being used. Very, very interesting slide. Other one, most of the big data and machine learning technologies are listed here. You can see for machine learning community, everything is for distributed processing, because we are not limited to only one simple laboratory or one system or one laptop. Everything should be in distributed environment. So that is why the technologies are now developed for distributed environment. So when you want to do machine learning in distributed environment, we have to go for Mahout. Okay, so Mahout is basically a scalable machine learning. It can scale up to any limit. Similarly, Spark. So Spark is actually a library of machine learning. These are all about machine learning. Distributed processing, there is a MapReduce. It's again a scalable programming paradigm. Okay, so very good kind of. Then scripting language, it's a high-level scripting, not like a normal scripting. High-level big scripting is there. Hive, it is again purely for skill for data warehousing. Big databases, people use Hive. Okay, these are all some traditional, I won't say traditional, the latest technologies and also the softwares which are used nowadays. Spark, in-memory data processing, very, very popular among machine learning community. See, most of the repeated jobs we pull it into the in-memory kind of thing, so that repetition will not happen. It's already there. Okay, so the program is very easy and it is faster. Similarly, Hadoop. Okay, Yarn is just to split the functionalities or the resources. It can manage the resource and split it according to the need. Then similarly, you can see HBase. Okay, HBase is a distributed database, not like your normal database or anything. Okay, NoSQL is very popular nowadays. See, NoSQL, you can write it in a human-like sentence, English-like sentence. We can pick up, the query can be picked up very easily nowadays. You don't have to depend on SQL. So NoSQL is very popular. Now, HDFS, it's a distributed file management system. It takes care of the storage and other things. Then we have a workflow, UZI. UZI is actually action-oriented diagrams. From all these things, it can build for the outside world. We wanted to communicate, and then action diagrams are built on them. Zookeeper will coordinate, and Scoop will exchange the data to the other network or anything. So these are very traditional, very popular and currently being used technologies for distributed applications. Actually, this has to be, you don't have to learn everything. See, everything is available. Only when you wanted to use a particular thing, you just learn that. Otherwise, you don't have to learn everything. Everything is now available as a package also, I told you. The only thing is, when we are working with, when we are collaborating with other researchers, or we collect data from various sources, we need these distributed programming or machine learning. We cannot be relying on a simple machine learning. We have to depend on distributed machine learning. That is the thing. Okay. This will give you how IoT and other technologies are playing a very vital role. See, this is something like a smart city or kind of thing. Smart buildings are there. IoT devices can be deployed. Fire alarms could be there. See, data transmission happens with these technology. WiMAX, Zigbee, LTE, low-RAN radio frequency, Bluetooth, Wi-Fi, near-field communication. All these things could be used, and it can be stored. Data can be harvested and stored, and analytics can be performed. Smart transportation, crowdsourcing. So you can pick up, you can put cameras and then pick up where the crowd is huge and why it is happening. All those things can be. UAVs can be used. Cellular towers, satellites, smart homes, emergency responders. See, this is what we are now. The smart cities are being built now with all these kind of features. So here it's going to be IoT purely, because IoT provides a very big solution for coordinating and collecting informations, and also big data is purely for your distributed and also storage and processing analytics. You wanted to do analytics on the data which is captured by IoT, then we have to do some analysis, then we have to build some prediction models. Or why we are developing a model? See, one every time you cannot learn. So every time we cannot be training a model. So we need to develop a model so that almost to some extent 80% it is purely trained, so that it can be used for future analysis. Now I'll show you some screenshots about what we did, a pilot project, which is a simulation model for geodynamic study. Okay, we developed a multi-layer feed-forward artificial neural network, which has got inputs from remote sensing, seismic data, geophysical data, geological data, pedological data, sand related, then geodynamic. All these are again fed into this. This is not a simple thing, it's a deep learning model. Okay, we are in the process of developing this. Okay, I will show you one more thing which we did a little longer back. What is the damage created by earthquakes? Okay, post-earthquake predictions. See, the parameters which we use was chemical reactions and pressure under the earth surface, location, because chemical reactions based on the components present, whether it is a metal or a gas or a liquid kind of thing, whatever is there, how they will react, those inputs are fed. Location, altitude, population density, oil reserves, dams, everything. So what we estimated was how much casualty will be there when something happens in the earthquake with a particular Richter scale. What is the energy released and how to prepare and we developed an earthquake impact analysis, a simple simulation model called EIA. This is a map. So you will have to select which country. Okay, so he has chosen Afghanistan here, and you have to select the zone. Then whether it is a sea or not, then it's going to estimate the damage kind of thing. A genetic algorithm was used, and it was estimated how many people will be killed. Suppose a Richter scale of 5 is happening at the Western Jammu and Kashmir, how many people could be killed at that region. Okay, and some mitigations, some alertness can be given. So these are all data actually from the data available from the resources. We developed a model. Similarly for sea, so for land, for sea also tsunami, I have to feed. See, this is a simple model which was developed. You have to pick up where is it, Bay of Bengal or what zone and other things. So it will predict what are the nearby countries and how the tsunami will, in what time, 15 minutes it will reach India. In Bangladesh, 5 minutes it will reach. Okay, so where this earthquake is occurring, how tsunami is going to. So it's a simple, see, from the data available, some small data available, we developed a model. It could be scaled to a further extent. These are all some informations which we picked up for how much magnitude, what is the latitude, longitude, at which depth the earthquake is happening, what is the region and area. Okay, so this value is very, very vital for us because we can build a model of that over that. Finally, I will just conclude. I think I've taken much time. See, this is a very, very interesting thing. Hype cycle. Every year, Gartner releases this cycle. Okay, for researchers, I urge you to go through this cycle. This will give you in which technology we have to concentrate more. See, it moves from innovation trigger to peak of inflated expectations, trough of disillusionment, slope of enlightenment, and plateau. So slowly, you can see what is peak at 2020. I think it is 2021. It is non-fungible tokens, data fabric, and AI augmented software. And these are all the technologies now at the peak. See, this will give you some information. See, most of the companies, what they do is they invest based on this hype cycle, even though it's called a hype cycle, but it is happening. If you want to develop as a startup, if you want to develop something, you have to invest in these technologies so that it will be good. Always it is best to invest in the upper thing, not in the down. Okay, the trough of disillusionment, you don't have to invest on this because it may go down. So please have a look at the hype cycle. And these are some of the trends which are happening in machine learning and AI. Nowadays, I think how far it is useful, I just highlight automated machine learning, explainable AI, conversational AI, generative adversarial net scans, very popular nowadays. Convergence of IoT and AI is happening, and AR, VR is very, very popular nowadays. The current trend is augmented and virtual reality. Plenty of solutions are available in AR, VR, even for your disaster management. Okay. So these are some of the very popular trends nowadays happening in the machine learning community. It could be useful for the disaster management applications also. This is the final slide. I have some tips for your researchers. See, you don't have to believe everything. See, don't believe everything in social media or people perceptions. Even though you get some inputs from that, you don't have to believe everything. Okay. Please ask questions. Why not, and how and all. Read a lot. That's the first point. You have to read a lot of books, e-magazines, technical articles, and also you can do some MOOCs, massive open courseware available, free. Now look out for the latest trends, Gartner cycle, or articles by experts. Nowadays, YouTube gives you a lot of information. The latest talk, TED Talks are available. Choose a problem and provide solutions for the current problem of the world. See, the current problem is COVID. Okay. And also disaster management. A lot of things I told you, it's a lot of things are happening. If you provide solutions for these kind of problems, then your research is very, very valid. And you get, even if you invest something as a company or a startup, you get a lot of money for that. Try to use others' intelligence and data. Don't have to build or capture data. It's already available. Something is available in Kaggle or archive.ics or GitHub, Elite Data Science. See, these are all some of the very interesting portals where others' intelligence, they are posting a lot. You can pick up and then use it for your research. Okay. So that's the thing. So that's what I wanted to conclude. Any questions are there? If I'm happy to answer.
Thank you, sir. It is indeed a very informative session. As said by the most of the participants, there are few questions.
Yes.
One question is regarding one person that while carrying out landslide susceptibility mapping, he's getting a validation accuracy of 98% every time. What should we have to do to prevent the model for overfitting on the data?
What do you want? What is the last line?
Overfitting of the data. What to do to prevent the model from overfitting on the data?
See, a very good question. See, underfitting and overfitting are the very, very basic problems in machine learning community. See, one thing is you have to worry about the features. Okay. Either you increase the number of features or increase the number of patterns, or that means the type of data what you capture from the features. My advice would be to increase the number of features. That will solve your problem. Number of input parameters. Okay. Rather than increasing the number of data or the patterns, what we call it, as every row is called a pattern. That also will solve some point. But you have to strike a balance between them. Even the underfitting, overfitting problem is not at all solvable. But you have to strike a balance. That is my solution.
Yes. Another question, could you please explain the level of accuracy with time we can achieve through AI or ML technology for DM mitigation? What will be the accuracy when we use
explain the level of
intelligence?
accuracy with the time we can achieve through AI or ML?
Yeah.
See, it depends on the problem, sir. See, when we have image or audio or video kind of thing, not much accuracy is possible because still it is being explored. For example, in speech and audio, we could not go beyond 85 or 90. I would say 90. Okay, not 100%, but 99% even we are not able to achieve. Similarly, for videos, very, but in a normal numerical value, even 99.9. You see, my advice is don't aim for 100%. Okay, when you develop a model which is very perfect, that is 100%, then it is not at all a model. Okay, in future you cannot learn anything. It becomes a lookup table. It is not a model. It's not a machine learning model. You cannot make the system learn. See how we human beings are learning. Every day we are learning. Okay, so it's not that I've learned everything. I'm a perfect person. Every day we are learning. We are fine tuning ourselves. That means we are not 100%. That means there should be some error always into that. That's what I tell my students also. Always have some error in your system. Error in the sense, some small percentage of thing which is left out for future kind of thing. So don't aim for 100%. But in case of image, video, or audio, still we are not able to achieve good accuracy. That is the question.
Thank you, sir. That's the end of the questions. There's a general, on general announcement. Many participants are interested in the presentations of the speakers. So I would like to inform them that we will collect the presentations because some of the speakers may have shared their unpublished presentation also. So we will request the speakers to share with us, and then we will be sharing the presentation to the participants. So we will
there is one more question there. I think Vijaya Pulusuri.
Yeah, there is one. Sorry, sir.
Yeah, for people like me who don't know machine learning, how to learn it? That's a very good question. See, machine learning, please be thorough with statistics. Okay, learn basic statistics. That's more than enough. Then you can do some online courses. Nowadays, edX, Coursera, NPTEL, they're all providing a lot of machine learning basic fundamental courses. I think NPTEL charges only a small amount, but Coursera, there are free courses available. edX is also there. Please learn online courses. Register 3 weeks, even 12 weeks courses are available. It's very easy. See, a layman can learn it. Basic mathematics skill is enough. Okay, you don't have to worry about much about it. The linear algebra, statistics is more than enough. Thank you.
Thank you, sir. Over to you, Dr. Samuel.
Thank you, sir. It was a very informative session. Our speaker for the demo session is Dr. R. Shivakumar, Professor, Department of Civil Engineering and Coordinator, Earthquake Research Cell, SRM-ISD. Dr. Shivakumar has completed his PhD on Geoinformatics in Earth Sciences, Catchment Treatment Model from Bharatdasan University, Tiruchirappalli in 2001. His research interests are geoinformatics for water resources and watershed management, disaster management and mitigation studies, digital image processing and applications, hyperspectral remote sensing and its applications, geoinformatics in urban hydrology, and earthquake studies and mitigation. He was awarded Young Scientist for a research project by DST. He has completed 5 research projects. 6 of his research scholars have been awarded with a PhD degree. To add up to his professional experiences, he is a life member in Indian Society of Remote Sensing, Indian Society of Soil and Water Conservationists, Indian Society of Geomatics, ISTE, and ISCA. I now invite Dr. R. Shivakumar to present a demo on GIS customization for disaster studies, earthquake. I invite you, sir.
Able to see my presentation?
Okay, not it.
Nope. Yeah, please.
Yes,
Yeah,
sir.
yeah. Good afternoon to all. Almost my colleague, Professor Sridhar, has covered the entire spectrum of geospatial technology. I don't think so. I want to give more emphasis on that. But still, we want to go for one small demonstration what we have carried out. Mainly for earthquake information system, how you can able to develop the tool using a open source GIS software as well as proprietary software. Probably you know very well. One is a commercial, another is you can able to use it without any cost, right? So my title will be the customization GIS for disaster studies and EQS tool development. Normally, the geospatial technology generally includes remote sensing, geographical information system, global positioning system, other recent technologies. I think yesterday Dr. Nitin Kumar Tripathi has discussed about LIDAR remote sensing. Then tomorrow we are going to see advances in the microwave remote sensing. So a lot of databases are available nowadays. How it is being effectively used for disaster management. So one small component only I am going to discuss because everything almost discussed by my former speaker. So here our interest is what? Generally, I am going to discuss mostly on the earthquake information system which we require. What is the purpose generally? Any developmental activities if you are going, naturally you should know about that area. Normally after the construction, earthquake has occurred, so everything is collapsed. How we can able to avoid? Or we can able to say earthquake resistant structures. So in terms of civil engineering angle, we have to think about how I can able to go for building a earthquake resistant structures. Generally, when you study these things, you require all basic parameters about the terrain. So generally, if you see the definitions of this one, various definitions you have given by that, we have carried out a lot of work in the, especially the Sikkim and then other northeastern Himalayas and then say Andaman. A lot of publications have. I'm just showing you some of the well-known published in the high impact factor journals like Natural Hazard Springer and other things. So generally, what will happen? The Sikkim like that of area or Himalayan terrain, frequently we are getting earthquake. Probably we have collected near about 60,000 epicenter data and plotted overall India how many number of earthquakes occur frequently. That was already shown by my colleague Professor S. Sridhar when we developed using the R Python programming through which we can able to visualize the data. So similarly, what I would like to highlight here, why do you require this thing? Generally, you require this information system readily available for the planner or the development activist people. So the infrastructure development in the hilly terrain is definitely it is challenging. How we are talking about the tsunami, for example, tsunami has occurred in Chennai, it is unexpected one, right? But in a earthquake prone area, already if you have identified or landslide prone area already identified, at least you can able to properly plan your infrastructure. So now slowly we are moving from the remote sensing GIS angle to infrastructure related, then how we can able to use this GIS tool for that purpose. Okay, so this is the slide which I don't want to explain that. The last line only I want to read it. That is seismic information tool or EQIS, earthquake information tool. Which purpose we are doing? Existing structures are also you can able to protect. In civil engineering, normally we used to say is that how you can able to retrieve the structures. Then how you can able to prevent from the earthquake damages. So in this case, the GIS is effective tool. Generally, it is available in different GIS software. Normally, just now whatever he has discussed, lot of softwares are already available. But I would like to give you a small caution in this. You can write lot of codes, lot of programs, new tools you can develop. Only thing is very important is what kind of data input accuracy you are giving. Accordingly, you will get the output. That is very, very important. Otherwise, what will happen? System may not be knowing because you are the person writing the code and you are executing. It will give beautiful results. But one thing is very important because we have worked in very rugged terrains in Himalaya and other areas. We have seen what we are seeing sometimes in the satellite image may not be matching with the what we are seeing in the field, because it's very important. The accuracy is very, very important. So when you want to increase the accuracy, you should have some field knowledge. So anyway, that will be incorporating in this. So generally in the GIS platform, there is an advantages to design new visual interfaces. Normally customization. Normally we used to tell you have to analyze the data, you have to visualize the complex database. For example, I am using a hyperspectral data. Each and every band may be 1 TB data will be there. So you require the data mining technique. So quickly, how far you can able to retrieve the data according to your objective. So that's why it's called specific objective is important. So the tool can be developed as user's requirement using customization process. So generally the customization is how you can able to create a database user friendly, irrespective of the linguistics. You can able to create your own language also. So the objective of this work is to develop earthquake information system, the tool using the ARC object programming in Vishuvi, VB and then NODED framework that we tested with the Sikkim Himalayan region, because as I told you, we are associated with the earthquake research cell. Many people are there were involved in this one. Then second is the web-based applications. So one is for directly desktop, as well as second is the web-based using the open source GIS softwares. Now, just I would like to show you, this is the geo database which we have created. Just one or two slides only later to map I will be showing. I will not go to much detail on that. You can see the 3D model which we have created. You can see the 3 dimension of the Sikkim Himalayan terrain. Then elevation differences, how it is varying. Whatever the dots which you are seeing, those are all major location, and yellow dot or the star is the epicenter. So first we want to know what are the spatial distribution of the epicenter in the terrain. If in case if I want to go for the northern part of the area, you don't have much epicenter there, but you can see the southern part, or you can say the southwestern part, lot of earthquakes are there. So spatially, first you have to understand what is there in that. Second is that one or two maps means lot of database you require to create for any kind of disaster, because you should know what is the actual terrain conditions. Right, yesterday I think you can see the urban flat, each and every road has to be mapped. What is its elevation difference, even centimeter level, because when you are talking about the flood, you have to go for centimeter level accuracy. So this is one of the example which you are showing, creation of the database in the GIS, like your geological or landform and other thing. Right, now I am directly going to how you can able to generate the model using the digital elevation model. This area you cannot able to access. Right, it is a higher Himalayan terrain, that is also the top Tangu and other area. Of course, we have visited for our field work to understand about the actual, why I am going for drainage, what is the relationship between earthquake. I will come to later to that, because morphometry is the good indicator of the paleoseismology, old seismicity happening. Right, so these are all the drainage system we are demarcating from the GIS. Now I will go for the 3D model. Actually, you are sitting in the flight and observing. If many of you may be expert in the GIS, maybe who are all not having the GIS knowledge, they can able to understand about this. You are creating a 3D model sitting in your lab. Okay, so that's why you're going for a drainage using that. DEM is digital elevation model. I can able to create a 3-dimensional model of area. After that, I am trying to drape the state satellite image over that. This is actually the satellite data is overlaid on the DEM, digital elevation model. You can see that each and every drainages are very clear. Now, when I am going for a flash flood, yes, drainage is very, very important. When I am going for an earthquake or landslide related studies, same drainage is playing a role. That is, once you are developing a database, the same can be used for various disasters. Okay, so now directly I will be going for GIS customization. A lot of thematic maps we have developed. Just I have shown only the samples because we have less time. So within 15 minutes, I would like to wind up the things. So then the GIS customization in general, it is a process of computer-based programming in .NET framework. to analyze the database for quickly retrieve the informations. Even any kind of disaster, you cannot able to go during the disaster and then collect the data. Just like sir has told already, what are the different ways you can able to collect the data without directly going to the field during the disaster time. So that is already you are creating a database. Then you are going for customization, which involves the modification of standard graphical user interface. That means already any RGS or any kind of software you will take in, already modules are available, but you have to customize according to your wish. You can go for flood disaster studies, you can for urban flood studies. Yesterday, I think Dr. Tripathi has explained very well for urban flood disaster studies. Similarly, you can able to do a programming language you try to use is customize in GIS. So here we have used Visual Basic, C++ and Java. Then this GIS customization environment is the standard process across any kind of GIS and non-GIS application. So that is very important how you can able to use the tool, in which only we develop the seismic infosys tool for Sikkim Himalaya. So normally the flowchart will give you the how we have carried out that work. Probably some of you may be already using. Generally, GIS customization includes Visual Studio, ArcObject, and ArcGIS. Then you are developing the user interface, application development, and toolbar development. Again, I want to stress here the data input is very, very important. Okay. So various stages which we have developed. Stage 1 is the programming language selection and software interaction. That is very important. The compatibility is very, very important. So that's in this case, if you see the interaction between Visual Basic GIS software and the SDK, right? So similarly, you are going for GUI creation. That GUI creation, what are all the databases is required? It is very important. So stage 1 is first you are preparing the programming. After that, you are going for the classical user interface. Third stage, you are integrating in the GIS software. Either you can go for any kind of the software, very important, which program you are using, and compatibility is very important. Okay. So finally, you are designing of UPS tool. Finally, then what you are going to do is the tool implementation in RGS. These steps one by one, I will show you how we have done in your GIS customization. Probably some of you may be already well versed in this one. What are all the base comment where you have to start from there? You can see that you have the tool. When my project is there, all are UK, whatever you have done it. That is earthquake information system, the menu which you are developing in normal Visual Basics. Okay, just one or two comments only. I am just showing you. Now you can see how you can able to run the program to understand. Because first, as I told you, in the top bar you can see EQIST toolbar in the VB. Similarly, what are the different information and designing? All these components should be added into this. Now I will show you this one. So the programming for checkbox functioning. So where do you want, what kind of name you want to give it? All these things you can able to do it in the programming. So it may be depending upon what expert you are, which program you are strong. Accordingly, you can see that you just simply I can say dimension, if, then, else. These are all the normal functions, whatever we are doing. But very important thing is that which layer you want to study. For example, I am interested to study the seismic related. First, you should have the epicenter distribution. Second, depth of the earthquake, where it has happened. Then area where it is. So these are all the maps which you require to be generated perfectly in the GIS, what you call the softwares. After that only the input which you are able to give it. I am just giving you the toolbar, what you have seen here, EQIS tool. You can just see on the top it is there, earthquake information system. One is what, 1964 to 2014, but still we are updating up to 2024 data we have collected. So that form, that the corner, right down corner, if you see that, what are the functions I require? Because you have to plan it, right? What database you want to create it for the, what objective or the purpose. So first I have created the data, earthquake epicenter distributions. So it started from which year? 1964 to 2022 already we are having. Then magnitude is also very, I told you, huge amount of database is available. 60 to 70,000 data is available related to the whatever the study area which we are working, right? Similarly, what is the hypocentral distance? Then maybe elevation contour is also very important, as well as isoseismal line. That is equally wherever you have the same epicenter is distributed with the Richter scale. So that is also a customized tool. Now, as usual, some of you may be working in that. If you already completed the programming, go for debugging in the RGS. The latest versions are already available. Just for the demonstration purpose, we have used this. Now you can see the EQIS. What are all the components you have? General information about the terrain, earthquake information, then various database, that is thematic information. For example, you want to go for infrastructure development in Sikkim, Himalaya. First, you should know what is the slope, what is the epicenter distribution, what is the frequency of the landslide occur, road network, all thematic maps which you require. Because when I am going for any kind of developmental activities, first I have to study that area. So that means when you are developing this type of tools, very important thing is there, what the administrator or the executor or the engineer, which they are going to use your data for their objectives. So first one is the general information about the area, second is earthquake information, third is geospatial information, fourth is seismic micro vulnerability. If you are interested to go for flood disaster assessment, naturally what will happen? You will be changing all your thematic database, change in the coding, then add your whatever the data which you are interested. Okay, so the customized tool in which EQIS it is there. What are the components are there in this seismic micro vulnerability in which analytical informations. Okay, now step one is tool, second is customized, third is you are developing earthquake information system. After that, you are going for displaying whatever you want. Right now, you can see a single click in a window. That is, I am customizing according to my objective. Okay, what are the things you require? A geospatial information, different type of thematic. I can able to select what is the geological condition, geomorphological condition, soil character. Because I am going for a construction of a building in a slopey area, I have to study about what is the geological conditions, what is the soil properties, right? What is the existing, any fracture or faults are there in that? What is the degree of the slope? What is the relief? All parameters in a single window I can able to analyze. The other side of the thing is very, very important related to energy. How much of energy whenever the earthquake occurs, how much of energy is developed or triggering the earthquake, that is also very important. See, in a single window, I am able to take all the database whichever I require for my objectives. So you can ask the simple question, sir, everything is available in GIS? No, you are customizing according to your objective. That's why we are going for the information tool. Now you can see my interest is I want to using the one click button. That's why again I'm saying you don't require a big GIS knowledge or anything. Only you should know how to click the button. For example, I want to know state boundary, location, transportation network. A simple click, you can able to get all information. Now I am interested to see only earthquake epicenter distribution. So which year, what is the Richter scale? Everything may be available in the table database, but I want to integrate everything into the GIS platform according to my objective. So the information tool will help you to understand about what are the parameters before you are going for publications. Now again, what if I have already developed the epicenter distribution data, I can go for generation of the isoseismal line. These are all automatically we can able to generate. Next is what I am interested to go for only which area is very fluvial, highly elevated mountains, or where your earthquake epicenter is also more. I want to just see one site selection for that. You see this particular area, peak ground calculation, how many number of fractures are there? Because real time when we are working with the data, maybe sometimes the accuracy maybe you will be losing because you will not able to get all the data. But whatever data it is available, if it is good, then output also will be good. Now you see a map which is showing where you have many number of fractures are there. That is indicated by what I call the thrust, which is the symbol is given. In the left side, you can see one is the lineament, that is the fracture. Then second is the fault, means there is a movement in the fracture. After that, you are going for what are all the density of the lineament. That means another one, if you see that, I am interested to see, I want to click a button in one place. I should have all information in a single window because you require to give a condition, the soil should be like this, slope should be like this, right? Like this, all these things are favorable, then I can go for developmental activity. So that question you can ask using the EQIS tool. So that's why just I want to show only the display component. Next we can go for earthquake hazard assessment tool. That is another thing what, again I am going for that. One by one I am just clicking state boundary, major location, epicenter distribution. For example, I am interested to go for one construction near to that Gayatam, the center of that area. But see, many number of epicenters are there. But as per this thing, you have to go for the construction. Only thing what you have to choose, this area is highly seismic prone. Only you have to decide what kind of structure is favorable for that area, because you cannot avoid. So seismicity is high, so I will leave that area. You cannot do it because you have to anyway live with that one also. You cannot able to stop earthquake. Only precursors only we can able to develop. Now you can see here where my earthquake is very low or moderate or high or very high. Whatever you are seeing, that pink color is very high. Wherever you have that ash color is very high, then very severe. So when I am going for any kind of construction in that particular area, because real time we want to use the technology, that is very, very important. So I am interested to go for gazing. I want to go for construction. But as per your database showing earthquake hazard zone 6, this is we developed our own scale here. EHZ is we developed. That is very severe. That means if I am going for a hydropower project, you have to take utmost caution in this type of areas. So it is directly the administrator or planner or executor, they can dare to use it. After that, I can able to directly generate the report in that area. So what is the existing status of that area? The text report will give you idea about that. So how much of area is affected in, I can say the classification, if you see 0.8% of the area is coming under very severe. So 35% is low, 7 or 8% is very high. So now I am going for planning of any kind of infrastructure development, then you have to take caution. So this will be highly useful. Okay. Now I want to see, sir, we have gone for field work. How I can able to merge this? Yes, you click the button, automatically the same area, all informations will be shown. So that is what it is geo-tagged with the point which you have developed. This is already we have gone for field work and we have come back. Landslide prone areas or the urban or future wherever landslide can occur or earthquake triggered landslide, all these things database. Just I am showing you only simple example. So what is this one, this tool? So this tool is possible to display multiple layers in GIS platform using the same interface according to your objective. The tool developed helps in understanding the complex database which you can able to easily understandable form. That means you don't require a big knowledge of GIS, image processing, all these things. At least you should know what database you require. You click the button, automatically it will give you. So this customized tool can be used to analyze for seismological database. That is one thing. Second is what I don't want to get to much detail, but you have some limitations in this because you have to have integrated with proprietary software like RGS and other softwares. But now I want to overcome that. So what will happen here? In this case, go for WebGIS. That is, you are using customization in the quantum GIS also. So WebGIS generally what somebody may be sitting in Sikkim, they can able to browse. I will be doing my work here. The planner executor may be sitting in there. He can able to access the data for his developmental planning and other thing. So this general information, I don't think so you require. Now, Quantum GIS is the open source GIS software. That is also you can able to use it. You can able to already created the RGIS, all the database. Please bring into QGIS software. Then you can able to create the interaction between the Quantum GIS and the through the your WebGIS through plugin. So stage one is software interaction, integration of the GIS with the database. After that, you are going for designing. Same customized tool you are developing using the database which you are created even in RGS or some other platform, you are bringing in this. Right now, I am just going to how we have carried out this work. So the quantum GIS flattening, we are using the software same way you are using the customization tool development. Now you can see this we have carried out for Andaman region, because we have attempted for many regions of the, since I am just targeting only seismicity in this lecture, I don't want to go much detail on other disasters. So only one disaster we can use it. How we can be able to use this tool? This is developed in the QGIS. You can see that the same way, whatever you are seeing in the RGS, which I have shown you the customization, you can able to get, but here it is a open source. Okay, that is also in the WebGIS platform. You can see the same coding and other things are there. I don't want to go much detail onto that. But only thing what is very important thing is there, you are creating again the interface which you can able to see, that is internet GIS. I can simply say all the database, whatever I created different software, I can able to bring it into this. I can able to same way visualize in this. You just see that. Now my interest is for epicenter distribution, major locations, as well as what are all the watersheds are there in that area. So this is seismotectonic information using your HTML tool. So these are all, I don't want to go very detailed into active tectonic, this pure geological condition, but our interest is where the seismicity status is so high, that is related to Andaman, South Andaman, we have carried out that work. So this also, again, you are studying using the what you call the software visualization of the geospatial database in the HTML tool using the what you call the WebGIS platform. So one is the open source GIS software, another is the proprietary software. So the finally, whatever we have carried out, because everybody is asking, sir, can we share this PPT and other thing? Please go through this paper. I will be sharing. It is already published. All the details are given into that. Please go through it using the ArcPy, how we have customized tool in the seismic information system. The second paper, whatever just now I have developed, I have just discussed, myself and my colleague Dr. Sneha Shishkosh, we have carried out this EHAS tool for visualization and integrated in the geological information and then geoinformatics approach. This is already published in the environmental sciences paper. Please go through it. You can able to download, read it. The entire thing is already given. Maybe some of you may be attempted to use the customized tool development for any kind of disaster. That is the, as I told you in my what you call about the training program, when we are discussing many things, at least some of the things you can able to take it. Please implement it in your organization wherever you are working. You please disseminate the knowledge. That is the fruitful of our program also. So this paper also you can able to go through the entire thing already I have given. Okay. So I think with that I will conclude my talk. Thank you one and all. Please raise any questions if you have.
Thank you, sir. Participants, any questions you have? I request all the participants to fill the feedback form.
Dr. Kamalanandini, on information I would like to pass.
Yes, sir, please.
Many of the participants wants to fill the day one attendance. So we are posting it again. The participants who have already filled in the day one attendance form, please do not resubmit. Only the persons who have not filled or given the attendance form for day one, you can fill it. And I request all the participants to fill the day two attendance form. Although we will take the details from the your login details Zoom link, but still we request you to give your feedback through this Google form. Thank you. Over to you, Dr. Kamalanandini.
Thank you, sir. Participants, any questions?
I have one question. Sir, it is a very nice presentation, sir. I have question about customization. So when you display the map by using the tools, by using arc objects, you display only the static map, or you prepare the map by means of programming? Generally, for example, thematic map we prepare by means of like interpolation techniques. So you develop these interpolation techniques by means of our tool, or you display only the static map in the final outcome by means of our object?
Yeah, it's a very nice question. Actually, both the things that's why I have developed. What is the purpose of the programming is you are customizing according to your objective. Base information may be from your GIS that I am bringing to my customized tool where your interpolations and other thing is being carried out. For example, EQIS tool we have developed. When you click that button, automatically it is taking all the information from various thematic map and give you the solutions. So that means base development of the what you call the basic thematic database from GIS software. You are bringing everything to the GIS platform according to your tool what you are designing. That's why I told you what is your objective. Accordingly, you are deciding everything through the program. So that is very, very important. So maybe I think you can able to simply change the code. You can able to apply for other disaster also. That's why I told you, I have shown you the drainage map. Drainage map may be useful for your flash flood studies, soil erosion studies, landslide studies, and then you are going for the earthquake studies also, morphometric analysis. But the basic database which you are creating is from a GIS. But according to your objective, I am interested for flash flood means I will study the through the programming. I will tell which is a very steep slopes are there, along with the drainage is passing, that is dangerous place for flash flood in that area. That can be given by the software itself. The tool can be helpful. So that is the way. Only earthquake information system will help you. I am going for infrastructure development. Only map only you can prepare from the GIS, but all analysis has been done by the tool itself. Yeah, I hope I have cleared your doubt, sir.
Thank you. Thank you. Yes.
There is one question in the chat box.
Yeah, please.
Is there any program which can provide geolocation of epicenters?
No, programming, actually geolocation of always the epicenter is the source which you are getting from the existing. That means, for example, an earthquake has occurred in Sikkim Himalaya. That data you can able to get only from the IMD or in either organization. So that geolocation, along with that only they are giving this latitude, longitude, depth, as well as how many Richter scale. All the data you directly getting from the site itself, because you cannot go and then measure it. Yesterday, I think Dr. Pooja Chandra clearly mentioned there are a lot of instruments are placed all along the Himalaya and other area. 24 hours it is monitoring. That data you can able to get from the Ministry of the Census. Yes. Location, along with the location. Yeah. Along with the location to give. Yeah. Is it clear? I think I clear your doubt. I think who has asked? I clear your doubt.
Hope I could have given the answer for the participant.
The programming is being used to call all the information related to the earthquake for your analysis. Generally, geolocation means you are giving latitude, longitude of that particular epicenter, then Richter scale, along with that, whatever the PG and other details are already available. Yeah. Any other thing?
That's all.
Thank you, sir.
So,
Thank you
very
for
much.
your very informative presentation. The session ends for today. Tomorrow, the program will start by 10:30 a.m. There will be 2 lectures followed by 1 demo. And our speakers for tomorrow's session are Dr. Gulab Singh, CSRE, IITB, Mumbai, and Dr. Banamurthy, sir, retired Associate Director, NRSC, Hyderabad, and Dr. Rakesh Dubey, GIS Specialist, MAP IT, Bhopal. I request all the participants to kindly join by 10:30 a.m. tomorrow for the 3rd day of your technical session. Thank you.
So shall we end the meeting?
Shall we close the meeting?
What's up? Could you hear me?
Yes, sir.
Yes, sir. Yes,
What's
sir.
up? Could you hear me?
Yes, sir. Yes, sir. Can you? Yeah, please.
So today that as like yesterday, that information is required.
Okay, sir.
Today.
Yeah. Will be available, sir.
You have done yesterday nicely. So today
Okay.
also it is required.
Sure, sir. Sure. Yeah.
But please by 4:30.
Yeah. Today, I think no inauguration or anything. So definitely 3 speakers will be there. Okay, sir.
And
Right.
what happened within the attendance?
Yeah.
That name from NIDM and from your institute who are
Yes.
involved.
Yes, sir.
Say Dr. Sridharan, yourself,
Yeah.
and Dr. Kamalanadhi, those names to be deducted. I
Okay,
hope Mr. Purushottam is hearing
Yes, sir.
that
Yes,
the
sir.
person who are involved for this process, those names to be deducted in the attendance. Okay.
Yes, sir. We are removing it.
Yes. But yesterday it was there. But I whom I know, those names I have reduced. But please check today. Okay. Some of the persons, they are not involved from your department. Let their name to be there, so they will be eligible for the certificate. But those who are involved, say Dr. Snyasis Ghosh was there, his name was there. So like this, those names to be deducted. Okay. So please take care.
Actually, they have registered, so I included their name. So
No, that is true. They
Yes,
have
sir.
registered, but they are involved in this process. Okay.
Yes, sir. I'll remove them.
Your name also will not be there. Okay, so please
Yes, sir.
keep it in mind.
Yeah. Yes, sir. Sure, sir.
Okay. Or your name, only the professors who will be.
Sir,
I'll tell
actually,
you.
sir, I would like to just say one word, because Dr. Kamalanandini already registered as a participant. Later, we added her as a moderator. That's the reason. So I think, we will discuss, sir. That is, we'll discuss.
Okay, we'll
Yeah,
discuss.
we'll
And
discuss.
finally, I'll tell you.
Yeah,
Then on that.
Yeah. Okay, sir.
Okay, all the best.
So, okay.
Bye.
Okay,
Tomorrow
sir.
we are having
Yeah.
final day.
Yeah.
Yes, sir. Thank you, sir. Thank you very
So
much.
today we
Okay.
exceeded half an hour. Thank you, sir. Thank you very much.
Okay.
Yeah. Thank you.
Thank you, sir.
Bye. So I'll be quitting. Okay, bye.
Okay, sir. Yeah. இல்ல எண்ட் பண்ணிட்டு இல்ல கட் பண்ணுவோம். எப்படி நேத்து மறந்து போச்சு. அங்க ஃபர்ஸ்ட் ஸ்டாப் பண்ணுவோம் இல்லையா? ஃபர்ஸ்ட் ஸ்டாப் பண்ணுவோம் இல்லையா? இல்ல இது வந்து இது பண்ணல. ரெக்கார்ட்